In this section, we're exploring functions. Specifically, we want to know, is a relation a function? So we're going to develop a definition to determine that. And then we're going to look at the domain and the range of relations and functions. So on our warm-up here, we have two columns. We have column A and column B. In column A, each of these relations here, so relation 1, 2, and 3, each of those is a function. The output is a function of the input. And in column B, the output is not a function of the input. So we're trying to come up with a definition of what a function actually is. So looking at these relationships here, what I'm keying in on the right-hand side is I'm noticing that everything on the right-hand side has that repeated input. Now, it does happen on the left one time, but take a look at the output that we get. It's the same. If we look at the right-hand side, when we have an output of 0, we get an input of 0, we get an output of 0. If we have an output of or input of 0 again, we get an output of 8. That can't happen. That makes it not a function. Same thing in relation 2. Input of negative 2 gives us a 5, and then another time gives us 8. In relation 3, an input of negative 1 gives us 5, 8, and 4. 3 different outputs for the same input. And that's the characteristic of a non-function. So our classroom definition of a function is going to be this: a relation that pairs each element, and an element is just a thing, a number, if you will. Each element of the inputs with exactly one output. So if I plug in a number into a function, I know what I'm supposed to get. There is no guessing game. On the right-hand side, when we have those numbers, if I plugged in 0, it's a guess. Do I get 0 for the output or 8 for the output? If I plugged in negative 2 in this relationship, do I get 5 or 8? We don't want that. We want a predictability. So a key, to me anyway, with functions is that functions are very predictable. You know what they're going to do, and they do it. In section 1, we're going to look at some different ways to represent functions. We've got mapping diagrams as our first one. Notice how we're writing this. We said if y is a function of x. Here's going to be the key here, identifying what's your input and what's your output. Because again, when we get to more in-depth questions, we're not going to specifically tell you. And it's really the way that the function notation is written here. Y is a function of x. This indicates right here that of x indicates that x is my input. And we're talking about y being a function of that, so then y would be my output. What I'm going to do on these mapping diagrams is I'm going to go ahead and label my input versus my output. So we said that y is the output, so I'm going to label all my y's as O's for output. And my input was x, so I'm going to label the x bubble here as my I. What I'm looking for is, in my inputs, do I have any numbers that aren't predictable? Like if I plug a number in, or use my number from an x, that side of the mapping diagram, bring it over to the y, do I know what I'm supposed to get, or do I have to like make a choice? So looking at the first relation, if I have negative 2 for x, that only goes to one number, 0. I look at 3, that goes to one number. 5 goes to one number. And that's okay that 3 and 5 go to the same number because our input is 3, our input is 5, and they go to only one thing. So that is a function. In number 2, if we go from negative 1, we go to 3. 0 goes to negative 5. 8 goes to 2. Yes, that's a function. Very predictable. And here's where I run into the issue. Number 3, we have 7. 7 is our input, but notice that 7 goes to not only 3, but to 8 and to negative 4. That cannot happen and still be a function. So for this, we're going to say no, it's not a function. It's violated right there at 7. And then at 4, same idea here. We got 3 different inputs going to the same output. That is okay. The key is, do you know what you get when you plug in negative 3? Totally, we get 4. Do we know what we get when we plug in 6? Absolutely. It's still 4. If we plug in 1, we get 4. So that would be a function. In part B, notice that our statement is going to be reversed. Now we're saying if x is a function of y. So in this case, y is our input, and x is our output. So I'll go ahead and label the mapping diagram to reflect that. So if x is my output, I'm going to label those O's. And y is my input. So I'm going to label those I's. Nope. Didn't change color on me. Here we go. Let's try that again. And we'll erase it. Okay, so if we look at our inputs of being y, if we start with 0, that goes to -2. Okay, predictable. If we go from -1, oh, now we have to make a choice. Does it go to 3 or 5? That's not predictable. That's not a function. And number 6, 2 goes to 8, 3 goes to -1, -5 goes to 0. Yes, that's a function. In 7, 3, 8, and -4 all go to the same output, but again, the input is 3. It's predictable where it goes. So yes, that would be a function. But 8 fails because if we start at 4, we have 3 different things that we can go to. That is not a function. Now tables are kind of the same idea. Again, we're going to label what our input and our output is. Again, A is my input, so I'm going to label that as I. And I would recommend doing this until you get automatic with picking out inputs and outputs. So if you're kind of struggling with it, just read through the question, pick out that input and output, label it in the table before you can automatically say, okay, I know this is input and output. So in number 1, we're looking for inputs of -3, -1, and 1. I don't see any repeats there, so I'm going to identify that that is likely a function. In number 2, same thing, -2, -3, -4, different inputs, so yes. Number 3, 2, -1, and 6, different outputs. Same output, different inputs, but the same output. That's okay, because 2 definitely goes to 4, 6 definitely goes to 4. So that, again, is predictable. But 4 isn't. If we have -5, that goes to 7, and -5 also goes to 9. That's an impossibility. We can't plug in one number and get 2 different ones out. So that is not a function. And part B of that, again, we're just reversing that. So if we looked at the relationships here, now B would be your input, and then A would be your output. So you're looking for any repeating inputs for B. So 3 would not be a function, but everything else would. We've also got ordered pairs. Ordered pairs are going to give you, in a lot of cases, an x comma y, but it's not always going to be that way. We're going to have functions, so we have an f and a g in this case. We can use any letters we want. And when we list this out, generally speaking, our first number is going to be our input, and our second number is going to be our output. But that doesn't always happen that way, so we do want to make sure that we read it very carefully. Here we're saying g is a function of f. So we know that g is the output, and f is the input. So when we're looking for the function, or if the relation is a function, we're looking to see, do we have any repeating f coordinates? So that's our first coordinate. So I've got a 2, 3, 4, -2, and 4. Up there, we've got a problem right here. 4, 5, and 4, -3. If we're looking at the second relation, 5, 8, 10, -6, and 7, different things. They have the same output. Again, that is okay when we're relating to functions. It's not okay if the inputs are all the same and give us different outputs. Number 3, 2, 3, -1, -5, -4. I see a bunch of different numbers, so yes, that is a function. For some reason, I'm writing no, but it's yes, that is a function. And 4, we have 0, 0, 1, 1, 1, -1. There's a problem. Same input, different outputs. And then part B, again, we reverse it just like we have with the other relations. We also have ordered pairs. So again, this one, it's going to be critical for us to know which one's the x-axis and which one's the y-axis. The x-axis is going to be the one that goes left and right, y-axis up and down. we again want to identify inputs versus outputs. In this case, we know that x is the input just based on where it's written there, and we know that y is going to be our output. Now, just like we did with the table, just like we did with the mapping diagram, I think until this is automatic, you're going to want to label your axes. So we said y is the output, and x is our input. So I want to label those axes as such. So here's what I'm looking at. I'm looking to see, do we have a relation where each input only has one output? So I'm looking at my x coordinates, and essentially what I'm looking at is, if I go to this first point I see here, -2 for my x, I only see one output, 2. There's only one place where we get an output for -2. Same thing with -1. There's only one point that has that x coordinate. Same thing with 0, and 1, and 2, and 4. Each of those points has only one x coordinate that returns a point. -2 gives us 1 point, -1 gives us 1 point, and so on. So based on what I see here, yes, with x being the input, that is a function. Same thing with number 2, -3, -2, -1, 0. I'm not seeing any duplicate points for a particular x input. So yes, that is a function. In number 3, if I have an input of 0, I'm good to go. Here's where I run into problems. If my input is 1, I have 2 different y coordinates. That can't happen because now my function is no longer predictable. So that's no. And again, at 2, the same thing happens. And at 3, the same thing happens. That's not a function. But number 4 is. When we look at -3, -2, -1, 0, 1, 2, and 3, all of those work out. So yes, that would be a function. In part B, again, we're switching input and output. So now y is our input. And I'm going to label that. And x is our output. So let's label those. So now I'm looking at the y coordinate, so that changes my frame of reference. So if y is the input, so at -2 I've got 1 point, and at -1 I've got 1 point, at 1 I've got 1 point, but at 2 I have 2 values of x that get returned from that y input. So that is not a function. Number 6 looks good to go because every single y coordinate has only 1 point, so that's a yes. Number 3 or 7, I guess, go with the numbers. That looks good as well. Again, each y coordinate has 1 x coordinate matching up, so that's a yes. And number 8, it's just a miserable failure of a function. Because when we have a y coordinate of 2, there's 1, 2, 3, 4, 5, 6, 7 different x values that get returned from that function. So that is not going to be a function. And then our last relation is what's called a function diagram. And again, it's the same kind of thing. I really like, they look like mapping diagrams to me, but without the bubbles and without the numbers being specifically shown to us. If C is or D is a function of C, that means that C is our input and D is our output. Those arrows are kind of showing us where to go. We're going from the left to the right in this case. Contrast that with part B, we're going from the right to the left. What we're looking for is there any place where we branch off. So I'm not seeing anything in number 1 that shows that we have a branching off. Nothing in number 2 either. But 3, we run into the issue of right here, that input of that looks like 0 goes to 2 different places. The input of 2 goes to 3 different places. So that's not a function. These are. And then 4 looks good to go. Again, in part B, we reversed it. Now we're going right to left. So we're looking for branching off on this side. Don't see any. I see a branching off there, so that's a no. Branching off, that's a big no. And we seem to be okay here. So those are the different types of relation or representations of functions we're going to have, or relations, to determine if things are functions. In part 2, we're going to take a look at how do we find the domain and the range.